f of x equals square root of 5 plus x over x raised to the power of 5 halves. So find the f of 2, the f of x raised to the power of negative 2, the f of square root of 1 half, and the f of cotangent of pi over 3. First, we have an f2. So what we're gonna do first is we have to substitute x by 2. So f of 2 equals square root of 5 plus 2 over 2 raised to the power of 5 halves. And then we will simplify. 5 plus 2 equals 7. And then 2 raised to the power of 5 halves is square root of 2 raised to the power of 5. And we try to simplify the square root of 2 raised to the power of 5, which is, its simplified form is 4 square root of 2, and we'll just copy the square root of 7, and then we'll rationalize the denominator by multiplying to itself. So 7 square root of 7 over 4 square root of 2 times square root of 2 over square root of 2. So square root of 7 times square root of 2. So here, and 4 square root of 2 times square root of 2. So here also and then we'll go to simplify it. So square root of 7 times 2, 7 times 2 is equals to 14, and 4 times 2 is equals to 8, and this is our final answer. So the next value is the f of x raised to the power of negative 2. So again, we will just substitute it. So square root of 5 plus x raised to the power of negative 2 over x raised to the power of negative 2 quantity 5 halves. Then first, our exponent is negative, so to make it positive, we will look for its reciprocal. So the reciprocal of it is 1 over x squared, and then we will try to reciprocate also our denominator, which is x raised to the power of negative 5, y negative 5, because 2 times negative 2 times 5 halves is negative 5. So this is now its reciprocated form, and in this term we're trying to find the denominator inside the radical. So here it is, square root of our denominator is x squared, so x squared divide 1 is x squared times 5, 5x squared, x squared divide x squared is 1 times 1 is 1. So it is, and then we're gonna simplify. So x squared is a perfect square, so it becomes it becomes x since it is a perfect square. Then we try to cancel these two because they have common, which is also x, and our final answer is x raised to the power of 4 square root of 5x squared plus 1. So this is our final answer. Our third value is f of square root of 1/2. Again, we'll try to substitute, or we just substitute. So square root of 5 plus square root of 1/2 over square root of 1/2 quantity 5/2. So here it is, and we'll just derive the square root, or in our denominator we just derive the square root into 1/2 to simplify our forms. So here it is, we just simplified our denominator, 1 over 2 raised to the power of 5/4. And then we're trying to reciprocate this one, since this is denominator and we have to multiply these two, so we have to reciprocate it. So quantity x square root of 5 plus square root of 1/2 times 4th root of 2 to the raised to the power of 5. And then we try to expand this term to simplify. So 4th root of 5 plus square root of 1/2 squared quantity 4th root of 2 raised to the power of 5. Here it is, the 4th root of 5 plus square root of 1/2 quantity times 2 raised to the power of 5. And we're trying to make the we're trying to simplify the forms. So as we all know that the square of the binomial is a squared plus 2ab plus b squared. So here's the result, 25 plus 10 square root of 1/2 plus 1/2. And then the other one is 2 times 2 raised to the power of 4. Since we're trying to have the factors to reduce since we try to reduce the expression, this 2 raised to the power of 4 can be reduced by 4th root. So we can place this as 2 out of radicals. And here is our new expression. 2 4th root of 51 over 2 plus 10 square root of 1/2 quantity times 2. 51 over 2 because we just added the 25 and the 1/2. Next, we distributed the 2, so this becomes 2 square 4th root of 51 plus 20 square root of 1/2. And we will simplify this into 20 over square root of 2. And we have to rationalize this by multiplying to square root of 2, both numerator and denominator. So here's the result. Then 10 square root of 2, and we will just rewrite the rest. And we have here factors, because this is a perfect trinomial. Although this is binomial, but this can be a perfect trinomial. So we have to get its factors in this, and we will cancel the squared and the fourth root. So the fourth root will become square root. So here's our final answer: 2 square root of 1 plus 5 square root of 2. So our last value in a given equation of a function is f of cotangent of pi over 3. So as usual, we will substitute it. Square root of 5 plus cotangent of pi over 3 over cotangent of pi over 3 quantity 5/2. And then in the trigonometric values of tables, cotangent of pi over 3 are equals to square root of 3 over 3. So we will derive it to square root of 3 over 3. And here it is. Square root of 5 plus square root of 3 over 3 over square root of 3 over 3 quantity raised to the power of 5/2. There it is. We'll just simply copy this, our numerator, and then we'll distribute our. So we just have distributed our exponent in our denominator. So next, to multiply it in our numerator, we have to reciprocate our denominator. So here it is. The square root of 5 plus square root of 3 over 3 quantity square root of 3 raised to the power of 5 over square root of 3 raised to the power of 5/2. And then we'll just place the two terms which has radicals. Square root of 5 plus square root of 3 over 3 quantity 3 plus 3 square raised to the power of 5 over square root of 3 raised to the power of 5/2. At this point, we will write an expression as a product with the factor of square root of 3 raised to 5/2. So here it is, and then we'll cancel the two. Here. And this is our expression now. So square root of 5 plus square root of 3 over 3 quantity 3 raised to the power of 5 halves. And then we'll distribute the 3 raised to the power of 5 halves. So square root of 5 times 3 raised to the power of 5 halves plus square root of 3 times 3 raised to the power of 3 halves. So why 3 halves? Because we just have cancelled the denominator of this. So 5 halves minus 1 is 3 halves. And then we'll try to multiply them. So square root of 5 times 3 squared times square root of 3 plus square root of 3 times 3 raised to the 3 cubed. So here it is. So 5 times 9, so 3 squared is 9, so 5 times 9 is 45, and just copy the square root of 3 plus the square root of 3 times 3 cubed is 3 squared. And then we'll just copy this, and 3 squared is 9. So and then because they have factors, the 45 and the 9, we'll try to get the factors of them, so which is 9. Then we have to separate the 5 square root of 3 plus 1, and then square root of 9 is 3. So we'll place 3 out of radical, and here's our final answer, which is 3 square root of 5 square root of 3 plus 1. Here's our example in limit. So first we have to factor out. Factors of the x squared minus 5x minus 6 is r x plus 1 x minus 6, as well as in our denominator. So the factors are x minus 1 x plus 1. Then we have common factor, and we will cancel it out, x plus 1. So we have here x minus 6 and x minus 1. Then we will substitute the x, which is 3. So 3 minus 6, 3 minus 1. So 3 minus 6 is negative 3, and 3 minus 1 is 2. So here's our final answer. Here's our final answer. So here's our example. We'll take the derivative of y equals 2 x, quantity x raised to the power of negative 1 plus x to the power of negative 2, quantity squared. So using chain rule, we will get the derivative of this. So here's the formula. So the derivative of f of g equals to d over dg of f of g multiplied to d over dx times g. Now we let g equals 2x raised to the power of negative raised to the power, and we let g raised to the power of negative 1 plus x raised to the power of negative 2. So we will distribute it now. So d of d over g times g squared multiply to d over dx of x raised to the power of negative 1 plus x raised to the power of negative 2. And then the derivative of g squared is 2g, and the derivative of x raised to the power of negative 1 plus x raised to the power of negative 2 is negative 1x raised to the power of negative 2 minus 2x raised to the power of negative 3. Now let us substitute this g, which is, our g is x raised to the power of negative 1 plus x raised to the power of negative 2. Here it is. 2 times x raised to the power of negative 1 plus x raised to the power of negative 2 times times negative 1x raised to the power of negative 2 minus 2x raised to the power of negative 3. And then, in order to make our exponent positive, we will try to reciprocate our terms. So 2 times 1 over x, this is the reciprocated form of 1x over x raised to the power of negative 1 plus 1 over x squared. So this is its reciprocated form, times 1 over times negative 1 over x squared minus 2 over x cubed. At this point, we'll now try to find the least common denominator of the two, and here also. So the least common denominator of this is x squared. So x squared divide x is x times 1 is x. X squared divide x squared is 1 times 1 is 1. So the LCD of these two is x cubed minus x cubed divide x squared is x times negative 1 is negative x or x. X cubed divide x cubed is 1 times negative 2 is negative 2. And we will now simplify this form. So we will multiply the denominators. So the product of the denominators are x raised to the power of 5, and we'll just copy the numerator. So we will now try to evaluate their numerator. 2x times negative x is 2x, negative 2x squared. 2 times x times negative 2 is negative 4x. 2 times 1 times negative x is negative 2x. 2 times 1 times negative 2 is negative 4. So we'll just copy the denominator, which is x raised to the power of 5, and then we will try to reduce, or we collect the alike terms to reduce the expression and to get our final answer. So we have here negative 4x and negative 2x, which is the result is negative 6x. So here it is, negative 6x. So here it is, negative 6x, and this is our final answer, which is negative of 2x squared minus 6x plus 4 over x raised to the power of 5. Thank you.